calculus, this is fun. We are finding the derivative using differentiation rules. You see, in calculus, the first question is about first principles. And right after that, you come across the rules of differentiation. They usually give us 2 questions. Here we go. When we do the derivative, guys, by the rules of differentiation, we must check whether the question is ready for the derivative. And most of the time, we are not going to find it ready. So in step 1, we prepare the question for the derivative. Now, to do that, we check whether the expression given has the brackets. And if it has the brackets, remove the brackets by multiplication. And in the question, if we have the surds, convert the surd into a rational exponent. Let's say we have the nth root of x to the power of whatever number is given. That's equal to x to the power m over n, where m will be the exponent and n will be whatever is outside the root sign. Let's say we are given a cube root of x to the power 2. We can convert this into a rational exponent. Remember, rational means a fractional exponent. So we write it as x to the power 2 over 3. What's inside is 2. That will go to the numerator, the top part of the fraction. And then what's outside is 3, which will go to the bottom part of the fraction. What if nothing is written here? If nothing is written here, we always assume the number is 2. So in that case, it's going to end up as 2 over 2. So cube root of x squared, x to the power 2 over 3. In some cases, guys, we are going to have, let's say we are finding the derivative in terms of x. If x happens to be part of the denominator, like in this case, we're going to have to use the law of negative exponent, where we say 1 over x to the power n is equal to x to the power negative n. A good example here can be, let's say 1 over x to the power 3, which can be written as x to the power negative 3. So in this case, this will be ready for derivative. In some cases, we are going to have to split a fraction where the numerator consists of 2 or more terms, all sharing the same denominator. C belongs to A, it also belongs to B. So we're going to split this fraction and write it as A over C plus or minus B over C. So in this video, we're going to be treating questions where we're going to be splitting a fraction as well. Okay, what's next? There are times when we're going to need to factorize. Remember, factors were taught in grade 10, how to apply the common factor, the difference of 2 squares, quadratic trinomial, the sum or difference of 2 cubes. And what's next? The general knowledge. Like in this case, the application of exponential laws. We are going to be applying exponential laws whenever applicable. So we are talking about removing the brackets, removing the surds, removing the x from the denominator, splitting a fraction, factorizing, and general knowledge like exponential laws. So doing all these 6 things, depending on the question, will prepare the question for the derivative. That's our step 1. And in step 2, we find the derivative using the power rule, which is the main rule in finding the derivative. It says if we have ax to the power n, then to find the derivative, we take the exponent and multiply the coefficient of x. So we're going to say this n times a will give us n times a. Then we say n minus 1. So that's the exponent minus 1. That will be our derivative. Just a quick example. Let's say we have 3x to the power 4. Then the derivative is going to be exponent 4 will multiply the coefficient, which is 3. So 4 times 3 will give us 12x. Then from 4, the exponent, we subtract 1. So 4 minus 1, that's 3. That's the derivative. Now we have some other rules to note, guys. Just a couple of rules here to note. Any constant, its derivative is equal to 0. For instance, let's say we have 4x cubed again, but this time plus 2. So to find the derivative here, remember we apply the power rule. So 3 times 4, that's 12x. And from 3, the exponent, we subtract 1. So 3 minus 1, that's a 2. But this is a constant right here. So its derivative is 0. We don't even necessarily have to write it. So the final answer is simply 12x squared. Another rule, if we have ax, where a is the coefficient of x, the derivative is simply the coefficient a. As an example, if we have 2x, the derivative, we just write 2, the coefficient of x. Now let's do some mixed past exam questions. First question, determine dy dx if y is equal to all that. Now we are finding the derivative by rules of differentiation. Firstly, we check whether this is ready for the derivative, the power rule, and it's not ready because we see some brackets. We must first remove the brackets by multiplication. So we have y. We'll leave this negative alone and multiply this linear expression by the quadratic expression in the second brackets. X and x squared will give us x cubed. X and negative x, that's negative x squared. X and 1, that's positive x. So we are done with the x. Now we are going to 1. 1 times x squared, that's positive x squared. 1 times negative x, negative x. 1 times 1, positive 1, close brackets. Okay, before we involve this negative 1 outside the brackets, it's always a good idea after removing the brackets to check whether we have like terms or not. Let's see. X cubed, any other x cubed? Nope. So this is x cubed. This negative x squared is cancelling out the positive x squared. And this positive x is cancelling out the negative x. What do we have left? We are left with the 1. So this is plus 1, close brackets. Next, let's involve this negative 1 outside the brackets before it gets bored. So y is equal to negative times x cubed, that's going to be negative x cubed. Negative times positive 1, that's negative 1. And this is ready for derivative, the power rule. So we're going to say, therefore, dy over dx, that's the derivative, is equal to 3 will multiply the coefficient of x, which is negative 1. So 3 times negative 1 right here will give us negative 3x. Then from the exponent, we subtract 1. So 3 minus 1, 2. Negative 1, remember, this is a constant. It doesn't have x attached to it. So we just leave it at that. That's just 0. We don't even have to write it as 0. And checkmate. Next customer, please. Question 2. Determine d of all that over dx. Okay guys, we have different notations to express the derivative. In the first question we did, they said find dy over dx. So the notation we use to express the derivative will really depend on what we are given. But in this case, they are saying determine d, we are used to dy over dx. So that will mean whatever is in brackets here is our y. So this is the same as saying determine dy over dx. So let's check in the box and see whether this thing is ready for derivative or not. So this expression, guys, has no brackets, no fractions, no surds. We don't need to factorize. We don't have any fractions with x on the denominator, you see. So this is super ready for the derivative. This is equal to, we apply the power rule. So 2 times 3, that's 6x. 2 minus 1, that's 1 right here, which we don't have to write, by the way. The next part is negative 4x, where we simply write negative 4, according to the rules we have just learned. And checkmate. Next customer, please. Question 3. So guys, in each question, you might want to just pause the video and try it out yourself first, then continue watching. That will make you so happy. Determine dy dx if we are given all of this. Firstly, we check, is this ready for the derivative? No ways. We have the surds, we have x at the denominator right here. So let's check in the box which rule is applicable. The surd law, where we are going to change the surd into the rational exponent. The square root of x, we are changing it into an exponent and write x to the power. Okay, inside it's x to the power 1. Outside is 2. So we write x to the power 1 over 2. Over 2. Next part, minus. Now check this out. In this case, the target is not the 6 at the denominator. The target is the x at the denominator. Remember, we are finding the derivative in terms of x. The x is not allowed at the denominator. So we are going to apply this law of negative exponent right here in the box. We are going to change x cubed into a negative exponent. Now be careful, 6 has nothing to do with it. So we're going to write 1 over 6. It stays at the denominator, but x must rise and become x to the power negative 3. That's step 1. Now let's find the derivative. We're going to say, therefore, dy over dx is going to be... Okay, now before we find the derivative, there is something you must be aware of here. Remember, when we find the derivative, this half here needs to multiply the coefficient of x, which is 1 somewhere here. So if you prefer, you may write this as y is equal to 1 over 2, just to make the coefficient very clear. So 1 over 2 x to the power half minus 1 over 6 x to the power negative 3. Then the power rule for the derivative, dy over dx is equal to half will multiply half. So this exponent half times coefficient half will give us 1 over 4. X to the power exponent minus 1, that's half minus 1, which is going to be negative 1 over 2. Next part, exponent negative 3 times coefficient negative 1 over 6. Use your calculator, you will get positive 1 over 2. X to the power exponent negative 3 minus 1, we get negative 4. And checkmate. Next customer, please. Determine dx in brackets all that. Is this ready for power rule? Check it out. Is it ready? No ways. We have x at the denominator. So we are going to have to apply this rule in the box here. The rule of negative exponent. The x cubed must become a negative exponent. So the x cubed will become x to the power negative 3. Now this is ready for power rule. So since the expression is already saying dy, remember whatever is in brackets is like your y. So you read this uppercase d twice, dy dx. So to write the final answer as your derivative, you just don't repeat dx. You find the derivative of whatever is inside the brackets. So 2 will multiply 8 to get 16. X to the power 2 minus 1, which is just 1. So x to the power 1. Next part, negative 3 times 2. That's negative 6. X to the power exponent negative 3 minus 1. That's negative 4. And checkmate. Next, they're saying determine d in brackets, that's our y. So dy over dx. Is this ready for power rule? Not yet ready because we see the surds. We also see what? Just the surds. We're just going to deal with the surds, which is this rule right here in the box. I also see some general knowledge. Application of exponents in a way, or surd laws, another surd law. You will see when we get there. So we're going to write d over dx. We're going to break down the square root of 4 times x to the power 6. We can write it as root 4 times root x to the power 6. You remember this surd law that goes like, if you have the square root of a times b, you can break it down as the square root of a times the square root of b. So a in this case is 4 and b is x to the power 6. That's what happened. Next part, the square root of 2 is already broken down times x squared. So in this first step, we have just applied the general knowledge of a surd law. Now it's time for this other law right here. Changing the surd that has x to the power 6. We're going to change it into exponential form. So we still write d over dx. Okay, root 4 is 2 times x to the power what? 6 over 2. I'm not skipping a step here, guys. I just want us to see how we are going to arrive at whatever we are going to arrive at. Plus the square root of 2, you can just write it in surd form, times x squared. Okay, with all the patience we can have, guys, we still repeat d over dx 2 times x to the power, let's see, 6 over 2, that's 3. So that's going to give us x cubed plus root 2 times x squared. Now, some of you may be wondering, why aren't we changing the square root of 2 into an exponential form? We only change the x term into exponential form. So 2 is just a constant. Now this is super ready for power rule. We are going to say therefore we don't repeat d over dx. We just find the derivative of whatever is in the brackets, which is 3 times 2, giving us 6, x to the power, exponent 3 minus 1, that's 2. Next part, exponent 2 times root 2, that's giving us 2 root 2. X to the power 2 minus 1, that's just 1. So this is the final answer and checkmate. Okay, who is next? 5.2, just to make it more clear, this is g of x is equal to 3x to the power 4 right there, minus 4x squared plus 6 all over x squared. Is this ready for the derivative? Never. We have x squared at the denominator. So which concept are we going to apply here? Let's see. You will notice that the top part of this fraction has more than one term, but all of these 3 terms, 1, 2, 3 terms, all of these 3 terms share the common denominator. So we are going to split it like is the reverse of LCD. So we are applying this part in the box right here. We are going to split this fraction. So we write g of x is equal to, let's see, this x squared, firstly, it belongs to 3x to the power 4. So we write 3x to the power 4 over x squared. This x squared also belongs to negative 4x squared. So we write negative 4x squared, negative 4x squared over x squared plus 6 also deserves this x squared. So we have 6 over x squared. So x squared is still at the denominator. I see some cancelling out to do here, but you can also look at it this way in this part right here. You can just apply your general knowledge, guys, because we have base x and base x, exponent 4, exponent 2 at the denominator. What do we do when the bases are the same and we are dividing? Now, so we subtract exponents. So we are going to write 3x to the power 4 minus 2. That's exponent 4 minus exponent 2, giving us 2. So that's 3x squared. The next part, this one we simply cancel out because that's just x squared over x squared. They will cancel out. We are getting 4 plus. Now here there is nothing to cancel out. X squared doesn't have a partner to cancel out up there. So we are going to apply the law of negative exponent. This one right here. X squared at the denominator will jump up and become negative exponent. So we're going to write 6x to the power negative 2. This is now ready for the derivative. Therefore, derivative, which is g prime x, is equal to exponent 2 times 3, that's 6, x to the power exponent 2 minus 1, that's just 1. We don't need to write it. Minus the derivative of a constant number is 0. Next part, negative 2 times positive 6. That's negative 12. X to the power negative 2 minus 1, that's negative 3. Now let's write the final answer without this 0. The derivative is equal to 6x minus 12x to the power negative 3. And checkmate. Next, customer, please determine f prime x if fx is equal to all that. Okay guys, hopefully you have noticed that from the list of our concepts here, so far we have applied removal of brackets like in question 1. We have changed a surd into a rational exponent. We have applied this law of negative exponent. We have had to split a fraction. We even applied the general knowledge. What about factorization? This question gives us the opportunity to do that because you will notice that here at the top part of the fraction, we have x squared minus 9, which is the difference of 2 squares. I know it may be tempting to say, oh, let me just cancel out x squared and x, 9 and 3. No, we don't cancel out terms, we cancel out factors. Whenever you have minus or plus, those are terms, they are not factors. So we're going to factorize this, then we are going to cancel. The difference of 2 squares, we write 2 sets of brackets. We find the square root of x squared, which is x, minus the square root of 9, which is 3. In the other brackets, we simply change the sign. So we write x plus 3. If you like, you may start with x plus 3, then x minus 3. All over x minus 3. So the whole idea was to cancel out here. X minus 3 is going to cancel out x minus 3. And we are left with x plus 3, which is now ready for the derivative. So we're going to write therefore the derivative, which is f prime x, is equal to x is the same as 1x. So we just write the coefficient, which is 1 right there. That's 1. And the derivative of 3, which is a constant number, is just 0. So f prime x, the derivative is simply 1. Guys, there's something interesting about this question. Check this out. Remember in functions paper 1, we have y is mx plus c. And that's the form we are given here. This is y is x plus 3. And in the place of m, we have 1 here. And m represents what? The gradient, which is another way to say derivative. So the derivative of this expression is simply 1, and checkmate. Okay guys, like and subscribe. Let me know if you want part 2 of the rules of differentiation. Cheers.